welcome to the Shake Table Lab. I think you've seen it yesterday during the lab tour, but I want to say a few things about the specimen, and then also maybe we can move a little over, say a few words in the control room. So the specimen that we're testing is basically a rigid block. It's just a mass, but it's sitting, as you can see, it's sitting on the isolators at the bottom, the shiny parts. So those are triple friction pendulum isolators, 4 of them. And then to measure the shear forces, the interaction of the table with the specimen, we have load cells at the bottom, okay? And we are measuring shears and moments and axial loads. But for these demos today, what we're using is just the 2 shears. So we'll be running demonstrations where we have an analytical substructure under this. So it's basically the example I showed in the presentation, the tall building application that we're showing today. So we have a tall building, which is, for the first test, we're modeling it super simple as a 1 degree of freedom system, okay? And but the mass on that 1 degree of freedom system is fairly large compared to the mass of what this could be looked at as a tune mass damper. So the ratio is like, I think this is about 56 kips of mass right now. Our building is about 450 kips of mass. So we're running this in longitudinal direction first, the first test that we're doing, with a 1 degree of freedom system. And we do this for a motion which is 100% of the motion that would be for that building. And then we'll try to increase it to make it a little more exciting. We'll run a second demo where we run it at 150%. Then we will switch to a model which is a 5 degree of freedom model for the substructure instead of a 1 degree of freedom model to make it more complicated, so that we can see more if higher mode effects have any influence on the response of this, okay? And we'll do this again in longitudinal. And then we will switch to a model where we're running it in both directions, so longitudinal and lateral at the same time, so 2D. We'll not do the rotations for this demo today, but we'll do a 2D test, which is going to be pretty exciting, I think. So that's that about the specimen and the sequence of tests that we're going to do. Now if we can move a little bit over, we're not going to go into the control room, but we can see through the window of the control room. We're going to say a few things about that. So just crowd around here so we can all sort of see inside.
Very bizarre.
So this is the Shake Table control room. We basically sort of have 2 rows in here of people working. So the very front row is actually the controller itself, the interface to the controller. So that would be over there on the right hand side. We have the MTS 469D controller interface. So Salim is operating that. And then in the back row, the second row there where the 2 monitors are, the 2 big machines on the right hand side, that's kind of the hybrid interface row there, okay? So that's where we're running. We have the 2 machines. One of them is the XPC host, the other one is the XPC target, similarly to what we've seen yesterday in the other lab. And so the XPC host is the one where we're running the numerical analysis. So that's where we're running OpenSeas and OpenFresco on. And then the XPC target, which is sitting next to it, has the predictor corrector model on it, with the ATS compensator on it. And all of those machines are connected through the fiber optic cables. So you can see there the 2 machines, the orange cables that come out of it, those are the fiber optic cables that connect everything together through ScramNet GT. And then in the very back you see on the right hand side in the corner, that's actually the MTS, the 469D controller. And then on the left hand side, that's some signal conditioner kind of stuff that we need there. That's from like older things, but we're currently feeding the signals from the load cells through that, the other box there on the left, the Pacific box, through that into the MTS controller where the conditioners are. So that's how we get the forces back. So that's how the system works. So for the demo itself now, I would suggest that all of you that you go into the back part, kind of behind the camera, and observe the test from over there.
On the Shake Table?
Not on the Shake Table. No, thank you.
Did you make those computers?
Yeah, I built those computers. Table. So this table actually is like all closed off below the pit. Everything is closed off and it's pressurized. So it's like air pressure down there. And the air pressure is basically counteracting the weight of the table itself and the specimen that is sitting on the table. So because it's such a big area, we don't actually need that much air pressure to counteract that weight, okay? And if we do that, then the control of the vertical, for the vertical actuators becomes much easier because it's already compact, so you're not pushing against the weight of the table and the specimen, you're really just doing the movement because the air is already doing that job. So the reason that we have a few more minutes is that the air pressure takes a little time to come up. Okay, because the whole chamber is getting pressure. One thing I didn't mention is I wanted to say maybe a couple words about the control that we're doing right now. So we are using the TVC, the MTS TVC controller, the 3-variable controller, but we are actually not using all the parts in it. So on the feed, if you remember from Selim's presentation, we have a feedback loop and we have the feed forward part on the TVC. And for each one of those we can do the 3 variables. And so on the feedback one, we're using displacement feedback, velocity feedback and acceleration feedback. But on the feed forward part, we're only doing it on the displacement. We're currently not having anything on the feed forward for velocity, acceleration, and there's even a jerk there. So all those are set to 0. Because we want to be more, like basically we're taking derivatives when we do this, okay? So our commands that are coming from the analytical part of the test, that are going through our predictor corrector model, those commands are basically displacements. And so what then the TVC does, it will take derivatives and create the velocity, acceleration and the jerk. So that's the part that it was also a Simulink plot that Selim showed. And so when we do these derivatives, they're not very clean signals. And so it becomes a little tricky. So that's why we are currently not using, in the feed forward part, we're not using those. And we're only using the one on the displacement. So it's better behaved. So that's one thing I forgot to mention.
All the changes have happened on the computer. So the model now, it's a little more detailed model, has higher degrees of freedom, and so you will see a little more movement. So same test will be repeated again in the same X direction. Yeah. Now we're going to do the two-dimensional motion. So it will move in X and Y. So what you're seeing is, as soon as the earthquake starts, there is a little bit more of the motion, and then the triple pendulum bearing starts kicking in, and in a way the tune mass damper is effective. Once it starts moving, the motion dies down. Okay, so that's why you see something happening followed by kind of a slowdown, which really means that the tune mass damper was working. Okay, so we don't get an impressive test, and that's a good thing. Okay, so most of the stuff is happening in the computer. So what we will do is, when we are back in the classroom, I'll have Andreas do some demonstration of what happened behind the scenes that you are seeing in the front here.